Okay, here's questions 2A and B. We'll try to get them both done in one video there on page 49. So this is kind of a theoretical question. They're trying to get you to see if you really understand the intricacies of genetics here. So it's not the same type of problem-solving question we've experienced in the past. But let's go through it and see if we can figure it out. So it says mating a tan mouse and a black mouse produces many different offspring. Geneticists notice that one of the offspring is albino. So if it's albino, we know that offspring, little c's. We don't know what the other one is, but we know they must have little c recessive alleles, saying that there's no pigment going to be produced. The question for 2A is indicate the genotype of the tan parent. Okay, so if it's a tan parent, it must have, and that's this parent right here, it must have a capital C for it to be tanned. The other allele, at this point, we don't really know, although it has given us some indication to be able to fill that in. To be tanned, we know that it must have two little b's to be tanned, according to our legend that we've done in the past. Because there was an albino offspring with these two guys here, with mating of the tan and the black mouse, we know that this tan mouse must have a little c. Has to, right? For there to be able to produce, because again, if you have any albinos in the offspring, both parents must have contributed one of these little c's. So, hopefully you get that. That's the answer right there for the tan. For the black, how do you determine the black? Well, it just said that the black and the tan had an albino. So to be black, you must have a capital C. And because they, same thing, produced a albino when they mated those guys, this black guy must have a little c as well. Okay? And that's who donated the other c to produce an albino offspring. Must have a capital B to be black. Now the question is, what is this other allele? Because if you're black, it doesn't say anywhere in the question if it's homo black, capital B, or heterozygous black, capital B, little b. How could we determine that? And the question is, like always, we've seen this come up and pop up a few times before. You'll see it for your exam and for your final, is you're going to do a test cross. Okay? And in this case, we're going to do a test cross with a tanned. Okay? We're going to do it with a tanned one. Now, it wouldn't make sense to do an albino because that's going to mess it up with this polygenetic question. We're going to do a tan one. Okay? So two recessive little b's. That's what we're after. Now, how could you tell what the genotype is? And this is where the theoretical part comes in. If you had any tan offspring, so let's say some of the babies were little b's. Now we're able to say, well, that parent, the test cross, contributed one of the little b's. The black tanned mouse must be contributing the other. And now we know that they're heterozygous. Make sense? If you always ended up, now you are going to end up with some albinos here, right? You are going to get some albinos. And if you do, that's okay. But if you ever get tan, we now know that this black parent has to be heterozygous. If they are always albino and let's say black, always black, then we might say that that might be a capital B, capital B. So again, theoretical question. They're just trying to get you to understand the concept of a test cross, looking at offspring, and with that offspring, theoretically, what could that genotype of that black parent be? And they just want you to articulate that. So anything like that, you'd be fine. Any issues, just give me an email. Thanks, guys.